In the second lesson, we learned about how to transform and graph cubic functions. Here is the parent function, which we can see here as x cubed, and we can see the growth rate here of the cubic function, and then we can see here the graph here. It has this like anchor or vertex point here at 0, 0. And we're going to see how we can transform. Now, this transformation is just like it was with quadratics and just like it was with logarithmic functions. So for example, if I were to add 2 to this, add 2, we would see that the graph would be shifted up 2. And we can see that by that green function there. Now, if I subtracted 2, change this to subtracted 2 as well, you can see that points all move downwards too. Now we can also move these left to right. And just like with cubic and logarithmic functions, we can do that by subtracting directly to the x. And so we can see that in here. We put parentheses around here. So if I were to, let's see, subtract 2, just like with cubic and logarithmic, instead of moving left 2, it moves right 2. Inside the parentheses, it moves the opposite direction of the sign. So if I add 2 instead, it will move it left 2. And additionally, we can do these at the same time. So I can move it left or right and up and down all at the same time. So I could move this left 2, and I could also move it up 5 at the same time. And we can see here on the table, and I will, we can see here on the table that our vertex here is visible at that point where it goes, where there's a difference of 1 on either side. So 4, 5, 6, that 4, 5, 6, this is our vertex. Now, if I change this to, let's say, -1, move it right 1, now our vertex here is at 1, 5, and we can see that 4, 5, 6 right here, and that's 4, 5, 6 is just they're all 1 apart from each other here. And if I change this to, let's say, -3, we can see that vertex in the table. So you're at 1 as we're changing by 1, -4, -3, -2. And that vertex is right here. We could also see it if we looked at the differences too, and seeing that the differences mirror around that point right here. Um, but anyways, we can also see it in the equation with that. And so our vertex here, or that like anchor point, is right 1, down 3. Now there's another thing that we can do to transform this graph, and that would be to, if we make it negative on the front, now it flips, it reflects. And so it's decreasing now. And the final thing that we can do besides reflecting is we can stretch. So if we were to, let's say, double, and we're going to go back here to our basic function here, and we could do these all at the same time. If we were to, let's say, double, now all the outputs double in value. Instead of being 1, 1, it's 1, 2. Instead of being 2, 8, it's 2, 16. Instead of being 3, 27, it's 3, 54. I could triple them, and it just stretches and get larger. I can also make them smaller and make it wider, just like we did with parabolas and quadratics. So this is how we can transform cubic functions the same way we did with logarithmics and quadratic functions.